Hi and welcome to Geeks for Geeks. Can I have a quick +1 in the chat if I'm visible as well as equally audible? Then we would start right away. But before that, let me just turn on my preview screen so that I know that yes, I'm visible or not. Hi and welcome to Geeks. Okay, fair enough. I'm fairly visible as well as equally audible. Let me just refresh the message, refresh the page so that I start receiving the text that you sent to me. Yes, let me just lower down the quality so it won't hinder the quality of the stream. And yes, we are live. Fair enough. Today we would be solving yesterday's problem of the day. Okay, that is find prime numbers in a range. This problem appeared in Qualcomm, GE, and one more company. And this problem has quite a great success percentage, that is 68%, and this is a medium level problem. Okay, so now let us read and understand the problem statement very carefully. But hi Vigneshwaran, hi, I'm fine. What about you? So we are given two integers m and n, and you need to generate all prime numbers from m to n. Okay, so basically दो रेंज दिया रहेगा और आपको उसके बीच में जितने प्राइम नंबर्स है उसको बताना है. Now what is a prime number? Prime number is a number which can't be divided by any number except itself and 1. Okay, so I would just write from where it is telling us prime, so I would just write itself and 1. Itself and 1. Fair enough. Now suppose we are given 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. These are the ranges of the given m to n. Okay, fair enough. So we would start from the 2. 2 is not a prime number. So we would move forward and we would go to 3. Okay, so 3 is a prime number. Okay, 5 is also a prime number. 4 can be divided by 2, 6 can be divided by 3, and 7 can't be divided by any number. And then we have 8. 8 can be divided by 4 as well as 2. Then we have 9, which can be divided by 3. Then we have 10, which can be divided by 2 as well as 5 itself. Okay, that's why the answer to this is 2, 3, 5 and 7. Okay, 2, 3, 5 and 7. Okay, sorry, I mistakenly forgot the 2. Why? Because 2 has only two prime numbers, that is 1 and itself. Okay, that is why it also comes under the category of it. Now the second range is 2 to 5. 2 to 5, this range. Okay, so in this range it is quite clear, we have already pre-computed it. So we would simply say 2, 3 and 5. Okay, so basically we are not given a query type of thing, rather we are just given a range and we need to tell. Okay, fair enough. Now there are different ways to solve a problem. Okay, the first one is check each number. Okay, the first one, see, it is given the range from 1 to 3, so I would go to 1, I would go to 2, I would go to 3, and we would tell if it is a prime number or not. This is the first way the problem can be solved. The second way it can be solved by using sieve. Okay, what is sieve, how it is used, we would talk about it, but still as of now just understand that it can be solved using sieve. Now whenever we talk about a range, we are given a L range and we are given a R range, where here it is M and N. Okay, the same thing. So we can see that we can use a variation of the second step, that is segmented sieve. These are the three ways the problem can be solved. Now tell me if you want to learn these two techniques or not. Just the 9 of us, one is me, so there are 8 people. So please let me know if you want to know these two techniques or not. Till then I am just telling you the way to solve the problem using the first approach. So now what we can do is, as I told, that a prime number has only two, it can be divided, it can be divided by only two numbers. So see, 5 can also be divided by 2. I know it would return me a decimal value, but I want to say that if a number after division returns me an integer value, then it is divisible. First way. And the second way, this can be amplified more. How? I'm telling you that when 5 is divided by 2, the remainder is not equal to 0. If it is equal to 0, that means it is divisible. Fair enough? So let's go from the very basic level. So let us first check. Let's check a prime number and then we would check a non-prime number. So we would check 6. So for 6, we would go from 2. Why 2? Because we already know that even if it is divisible by 1, it won't affect the answer. So we would go from 1 till 5. Why 1 till 5? Because the number itself also falls in the category of divisible, so it won't come. So first we would 2 to 5. So first we would check by 2. 6 is divisible by 2. 6 divided by 2 is equals to 3, which returns an integer, and the remainder is 0, so it is divisible by 2. Then we would go to 3. 6 by 3 is equals to 2, which is also an integer, and the remainder is 0, so it would also tell us 3. Then 4. 6 by 4, the remainder is 2 and the value is not an integer, so you would say it is not divisible. Then we have 5. 5 also has a remainder of 1. This boils down to the fact that still we don't have any number. So what we can do is we can have a loop from 2 to n minus 1. Okay, and we can check each number. Okay, for each number we would run a loop from n to 2 to n minus 1. If we have any value where the number divided modulo this value, that is n, if the value is equals to 0, that means it is not prime. Else, if till the end we are not able to find a value, this boils down to the fact that yes, we have a prime number. Okay, so let us quickly see the implementation and then we would talk about prime sieve, okay, which is also known as sieve of parenthesis. So if the number is 2, that means it is a prime number. Okay, if the number is less than 2, okay, and it is divisible by 2, okay, we would read, or it is divisible by 2. So see, even numbers can't never be prime numbers. So if it is divisible by 2 or if it is 0, 1 or something, we won't do that. So 2 is already checked and 1 can't be a prime number. So we would start from 3 here. Okay, it depends upon the implementation. Okay, so 3 here, and then this thing I would tell you, don't worry about this. Then if the value returns to be divisible, then we would return false. Else, if till the end we are not able to find a divisor, okay, we would return true. Now what is this thing and what is this thing? So let us just see, we have already handled the case for even. So even is handled, we just need to check the odd. So if we are checking the odd, what we are doing is we are first checking 3. Then there is no point in checking 4. Why? Because 4 is an even number. Even if it is divisible, 2 would disrupt that answer. So 3, 5, 7, 9, 11. That is why this is I plus 2. Then why this thing? This thing means that I into I is less than n. Okay. If till this point only we are not able to find, that means we don't have a value. Okay. Fair enough. Now we would learn something known as sieve. Okay, which is also known as prime sieve and which is also known as the sieve method. Okay, is it working with normal prime checking logic? Which logic is good? Sieve a good sieve or iteration with simple prime checking logic? See, every approach is good. No approach is bad. It depends upon the efficiency. The calculation point is the efficiency point. Now the thing is that you should start with the basic checking of each number. Then you can go and write the sieve method. Then the interviewer would tell you to optimize you further, and then you can jump on to segmented sieve, and that's the best possible way. Okay, now let us understand sieve method. Okay, so in this sieve method, first we have an array of 1, 2, 3, 4, 5, 6, 7, 8, 9 and then 10. Okay, so let's have a array only. Okay, so this thing, okay, so let me just check till which point I am visible. Okay, I am visible till this point. Yes, okay, fair enough. So I would take care of the array till this point only, not that point, because I need to be visible too. Okay, fair enough. So let's just draw. Okay, fair enough. Now let's fill the values. Okay, so this is one, sorry, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 and 25. Basically we won't be having a matrix thing, but rather we would be having a whole array, but representing 25 numbers in a single line is very difficult. That's why I'm showing you in a matrix format. Now let us start with the iteration. So what I am claiming is we need to handle this one explicitly. Okay, just handle the one explicitly. Now I would come forward to 2. 2 is not marked till now. If 2 is not marked, we won't touch it. Okay, we won't touch it, and this would be marked explicitly. We won't touch 2, but we would touch the multiples of 2. So 2's second 2 multiplied with 2 is equals to 4. We would cancel out. 2 multiplied with 3 is equals to 6. We would cancel out. Then 8, then 10, then 12, then 14, then 16, then 18, then 20, then 22 and 24. Fair enough, we have this kind of thing. Then we come to 3. Okay, 3. So 3's next multiple is 6, which is already cancelled out by 2. Next multiple is 9, not cancelled out, so we would cancel out, start cancelling out. So whatever is not marked till now, we would consider it, but the multiples of them would be eliminated. Okay, and then 12, then 15, then 18, then 21, then 24, which is already marked. So till now we have 2 and 3. 4 is marked, so we won't touch it. We already know that it has been marked. So let's come to 5. So 5 is true, but the multiple of 5 won't be true. So the multiple of 5 is equals to 10, already marked, 15 already marked, 20 already marked, 25 is not marked, we would mark it. Then we have 7. So it would be good, but 7 to the 14 marked, 21 already marked, then 28 is not there. Then we have 11, so the next one will be 22, which is not there. Then we have 13, the next multiple is 16, which is also not there. So you would observe a very good thing here. You would observe that whatever is remaining at the end, we would have the prime numbers. The prime numbers are 2, 3, 5, 7, 11, 13 and then 17, 19 and 23. Okay, so क्या किया, फिर से समझा रहा हूं. एक पूरा एरे लिया, 1 को अलग से मार्क कर दिया कि वो प्राइम नहीं है, 2 से स्टार्ट किया. तो 2 अभी तक मार्क कोई भी 2 को मार्क नहीं कर पाया. तो 2 के सारे मल्टीपल्स 4, 6, 8, 10, 12, 14, 16, 18 सारे नॉट प्राइम मार्क हो जाएंगे और 2 वैसे का वैसे ही रह जाएगा. फिर 3 के पास जाएंगे, 3 को अभी तक किसी ने टच नहीं कर पाया. ओके, सो 3 का मल्टीपल 6, 9, 12, 15, 18 सारे मार्क हो जाएंगे. फिर 4 तो ऑलरेडी 2 से मार्क हो गया, सो उसको हम लोग टच नहीं करेंगे. फिर 5 का नेक्स्ट मल्टीपल 10, 15, 20, 25 ये सब मार्क कर देंगे. Fair enough, this is how we would do. और ये सिंगल एरे पे होगा. और whatever is would remain at the end, we would say that it is the prime numbers from starting to the particular value. So we can do that. Now tell me if this thing is clear to you or not. I tried my level best to make it happen, but still the main decision goes to you. Just tell me if things are clear to you or not. And what time at the problem of the day solution streamed? At 3 every day. Yes. So tell me if things are clear to you or not. Quickly tell me if things are clear to you or not. Thank you so much, Zaid. Okay. Now we would be doing a bit advanced. Okay. Bit advanced thing. Now the problem, see, whenever you are given this one, now let us talk about the space and time complexity of these two. Okay, see, so the space complexity would be order of n because we need to have an array of size n. So space complexity would be order of n. Time complexity would be how much? Time complexity, we are iterating on all the elements, so basically it would be n. Then we are getting a particular value, mark all its multiples. So we won't be digging deep into that, but still just understand that big O of n log n. Okay, so basically you can take it as n log n. Okay, so this is the space and the time complexity. Now how it is implemented, I would show you quickly. Okay, so just go with the flow and I would make you understand. Okay, this is good to go, and then let us just start. So int p of suppose 100, we would calculate the value still 100, and then what we would do is we would mark, okay, we would mark everything. For loop, we would have a for loop int I is equals to 0, I is less than 100. Okay, I is less than 100, and then I plus plus. Now we would get all the prime numbers less than 100. So we would mark p of I is equal to true initially, and then we told that we need to explicitly handle the case for 1. So p of 1 is equals to false, as well as p of, or we don't handle this. Okay, next what we would do is we would start a for loop. Int I is equals to 2, I is less than equal to 100, and I plus plus. For each element, what we would do is int j is equal to I multiplied with 2, because I is true, will remain true, and then j is less than I, and j would be less than equal to 100, and then j plus equals to I. That means it would get incremented. And when will this happen? If p of I is true. Okay, p of I should be true. Fair enough. Let's work with the formatting thing. Yeah, fair enough. So if p of I will be true, then we would start moving in I multiplied with 2, and j would be less than 100, and j plus I. Then what we would do is, this is absolutely very important, we would mark p of j as false. P of j would be made false, and then the sieve is complete. Now let us just print for the confirmation that yes, we have got this correct or not. So I is less than equal to 100, and then I plus plus. If p of I is true, then C out I. Okay, and then we would do that. Now एक बार revision कर लेता हूँ. Okay, so p of everything would be made true, we would and 1 is handled explicitly, we would go from 2 to 100. Then if the particular value is a prime number, then we would mark the multiples of prime number as not prime. Okay, this is what we have decided. We did that and we have written. So let's just print all the prime numbers. So see, all the prime numbers from 2 to less than 100. Okay, so even if we say that less than equal to 100, it is fine because 100 is not a prime number. So 2, 3, 5, 7, 11, 13, 41, 61, these all numbers. This is the simple code of prime sieve. So quickly tell me if things are clear to you or not, because I'm implementing it live from scratch. So I deserve at least a reply. Okay. Okay, fair enough. Yeah, Chirag, go ahead. So let's now move with the second part. This is on the bit advanced way. Okay. Now suppose you are given, so the name of this is segment sieve. Segmented sieve. Now suppose you are given a value L and R. The same way, suppose you are given the value 2 and 10, and you need to tell all the prime numbers that lie within this range. So all the prime numbers that lie within this range are what? 2, 3, 2, 3, 5 and 7. Okay, fair enough. So 2, 3, 5 and 7 are the prime numbers that is there within this range. Fair enough. So can you repeat why it was can you repeat why it was I plus 2? Yeah, fair enough. I'm just repeating. Okay, why it was I plus 2? See, the thing is that when we encountered that the first 2 is true, then we would mark the next multiple as false. Then 4 plus 2, again this. That is why the particular value is true, but we want the next multiple of it as false. This is why we are making the next one as this one false. So 2 would remain true, but 2 multiplied with 2, that is 4 would become false. This is what we are doing. Okay, now suppose you are told with a range. Okay, just like in the question that it is asked. So in this question we are told the range itself. Okay, so how to solve that? Now suppose you are asked with the range from 15, L is 15 and R is 25, and you are told to write all the prime numbers from 15 to 25. Now you first take out the prime numbers. Okay, take out the prime numbers of root of R. Okay, root of 25 is equals to 5, and the prime numbers less than 5 is how much? 2, 3, 4 is not there, 5 is there. Okay, now what we would do is we would have an array of the difference of the numbers. So basically we want how much long array? 15 plus 25, 15 and 25. So we want the array to be of value 10. Okay, so what we would do is we would have something like this. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, suppose this is equal to 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 and 25. This is the way. Now what I am claiming is mark all the multiples of 2 as false. So this one would turn out not prime, not prime, not prime, not prime, not prime. This one would be not prime. So 3 3 3s are 6, 6 3s are 9, 9 3s are 12, 12 plus 3 is equal to 15, So 15, then 18 is already marked, then 21 would be marked, then 24 is already marked. Then the multiples of 5. 5 multiplied with 2, 5, 5, 10. 10 is already, 10 is not there. 15 already marked, 20 already marked, then 25. We should mark it here. Then we are observing that 17, 19 and 23 are the numbers that are prime. Okay, and how can we have this level of array? So we can have this by mapping 0 with 15, 1 with 16, 2 with 17, 3 with 18, 4 with 19, 5 with 20, 6 with 21, 7 with 22, 8 with 23, 9 with 24 and 10 with 25. So basically the auxiliary space would be how much? R minus L plus 1. Okay, so R minus L, big O of R plus L, and first we need to calculate of big O of R, then all the multiples of that would be marked. Okay, hi Saurav, how are you? So this is segmented sieve. If you still want to get the code of it, that's absolutely very easy, but as this is on the bit advanced side and most of them won't be the audience of this, so I would be skipping this, but still I would be giving you a way to solve this. See, first take out all the prime numbers till less than equal to the floor value of the range R. Okay, and then do sieve method only, and then you map 0 with the values from L to R. Then you mark the multiples of whatever the values that we have got in the previous array. Whatever would remain would be the elements that is prime in this particular range. Okay, so now I hope things are clear to you. Okay, still I would wait for the next 1 minute to see if there is any doubt or not. If there is no doubt that is persisting, then I would turn off the session after this has elapsed. So tell me if things are clear to you or not. Okay, Zad, thanks a lot. Okay, Saurav, thanks a lot. Okay, so that's it for today. Thank you, Chirag. Thank you, Zaid. Thank you, Alok. Thank you, Saurav. Thank you, Zaid. Okay, that's it for today. Thank you and have a nice day. Keep coding. Stay safe.